this is number 20 on 4-5. Okay, to write a detailed proof of, well, we're going to do the two-column proof of FL is congruent to AK, so these are congruent, and SF is congruent to SK, so these are congruent, so that means these angles are congruent too. And M is midpoint of SF, so these are congruent. And N is midpoint of SK, so these are congruent. And you have to prove that AM is Rn. Okay, so if you have to prove these are congruent, then you probably have to make these two triangles congruent, right? So FMA is congruent to K and L. That's what you probably want to do. And then you got the angle congruent, and so these isosceles triangles, these angles are congruent, and and because these are congruent, these are actually have to be the same lengths, because so this is actually, this should be 2 and 2, 2 and 2, right? So these are congruent, and then this one you have to do the segment addition one. So this plus this have to equal this plus this, because these are congruent and this is shared, right? So this is going to be a long proof. So let's start with this, trying to prove FA is KL, and then we tackle with these, and then the angle is really the easiest one, so we leave it at the end. Right, so let's start with FL is AK. Right, so segment FL is congruent to segment AK, and that is given. Okay, and 2, segment FA is segment FL plus segment LA, and that is, let's just do both. The segment KL is segment AK plus segment LA, and that is segment addition postulate. Okay, and 3, how do we do this? All right, I realized I made a mistake. These are numbers, right? So we can make this a segment. So distance between these things, segment addition postulate, and then equals and plus only works with the distance. It doesn't work with a segment. So distance between FA is FL plus LA, and so forth. Okay, and now we also, so I forgot to write this one here. Well, all right. So I'm going to rewrite this. I have to change this to measure. So 2 should be FL equal AK. If segments are congruent, then they have equal measure, equal distance. Okay. All right, and then you can do segment addition. So FA equal FL plus LA, and KL equal AK plus LA, and that's segment addition postulate. And then you can substitute this into here. So FA is FL, oh no, let's do FA is AK plus LA, and substitution property of the step 2 and 3, right? So I substituted the AK into FL. So 5, it's substitution again. Now these are the same thing, so you can do FA equal KL. Again, this is substitution property of 3 and 4. Okay, and then now you have to make this congruent. Segment FA is congruent to segment KL. And if segment has equal distance or length, just call it length, you can call this length here too. Measure is for angle, length is for the segments, they are congruent. Okay, all right, so I got the side now. It took a long time to get the side. All right, and then let's get to these ones, right? So 7. M is midpoint of SF, and N is midpoint of SK. That's given. So that means by the midpoint theorem, FM is 1/2 of SF, and Kn is 1/2 of Ks, and this is midpoint theorem. Remember, the theorem is the one that has a 1/2, right? Now, the given says Sk is SF, so SF is congruent to Sk, that's given. And 10, so SF equal SK. If segment congruent, they have equal ranks. Okay, so since these are congruent, you can substitute this into here. So 11 is FM is 1/2 of SK, and that's substitution property of 8 and 10. Okay, and then you can substitute again FM equal Kn, because these are equal. Wait, what did I do? 1/2, no, this should be, yeah, SK. No, wait. SF, SK, SF. Oh yeah, SK, it's the same thing. I wrote KS, I got confused. Right, SK and SK. So these are the same. So you can do that. Okay, so Fn, that was the 11 and 8, right? 8 and 11. Okay. And so that was the side. Wait, Fm is Kn. Yeah, that's the corresponding order. All right. And I got the angle. The angle was from the isosceles triangle theorem. So you need the, you already said this, right? So we can use that. That says angle F is congruent to angle K, and that is isosceles triangle theorem, because it's not converse. The sides to the angle is the theorem. So that's an angle. So now I can say, wait, not 10, right? Not 10, 13. 13, it's getting long. 14, triangle FMA is congruent to triangle KNL, and that was side angle side. Goes through it. And then finally I can say that AM is congruent to LN by corresponding sides of congruent triangles are congruent. Phew, we're done.